Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we are back with wholesome new session of probability. Now, we have to understand the game of chances. This chapter is very important, and if you wish to have a great command over this chapter, I would suggest you to go through permutation combination first, and then you have to go with probability. Means on the bunch you have to club these two chapters and you have to study these two things together, and you can expect uh, 2 to 3 questions. Like, from my opinion, minimum would be 3 questions. So you will expect 3 questions from these two chapters. And if you are aiming for greater rank you have to get better marks. Okay, and these 3 questions you should attack, because it is less time consuming. In remaining chapters you have to invest time, then only you can extract those things, those 4 plus 4 marks plus 6 marks. But solving probability question and permutation combination question requires less amount of time, but greater amount of concentration and patience. Okay, you will require very less space to write down these things, but you have to think a lot. Okay, so this makes this chapter to be more interesting. Now, so one by one we will go through the basics of this chapter. First we will create the foundation, then we will jump on to the question part. Okay, now the first part is random experiment. So first try to understand what does random experiment means. Suppose you are doing something, okay, and it has more than one outcomes. Like, suppose you are throwing a dice, so you know that there is a possibility of occurrence of 1 2 3 4 5 and 6. Okay, so outcome is more than one, it's not sure event. Okay, so outcome should be more than one, and you cannot predict the outcome. Okay, you cannot say that you will have this only and that would be the like truth only. Like, suppose you are like about to switch on the bike. Okay, so you know if I'll press this button it will switch, if I'll kick the bike will start. Okay, so it is sure event, so you cannot say that it is a random experiment. Okay, throwing a dice is an random experiment, tossing a coin is an random experiment, uh, like just picking up one random card from the deck of 52 cards is random event. Okay, I hope now you're good with random experiment. Then we have to understand sample space. What is sample space? Suppose that you know that these are the possible outcomes, and if you put those possible outcomes into a bracket, curly braces, that thing will become sample space. Like, for tossing a coin it is head and tail, for throwing a dice it is 1 2 3 4 5 and 6, and it depends upon the number of dice thrown, number of coins being tossed. Okay, so this is sample space. Then we have an event. So what is event? Event, you can say that it is subset of the sample set. Okay, means suppose that you wish to have head. Okay, so that is being considered as event. If you wish to have 6 to be on the top of the dice, it's an event. Okay, so favorable outcome, unfavorable outcome are events. I hope this thing is clear. Then we have complementary of an event. Means suppose you are assuming something that I will have a 6, so everything apart from 6 is complementary. Okay, it is represented by a bar, a to the power c, a dash. Okay, and you should know that probability of occurrence of something plus probability of not occurrence of that thing will always sum up to 1. Okay, now we have to understand probability of an event. So what is probability? Probability is, first on the numerator you have to write down number of favorable outcomes. So suppose that you are throwing a dice and you wish to have 6 on the top face. So your favorable outcome is 6. So the number of favorable outcome is only 1. Okay, so on the numerator you will be writing 1. On the denominator you have to write down total number of outcomes, means number of elements in sample space. Okay, so it would be 6. So the probability will become 1 by 6. I hope the idea is clear. Okay, then you can say that the range of probability will goes from 0 to 1, both included. The probability of an event will be 0 if it is impossible event. Suppose you are throwing a dice and you wish to have tail. It's not possible, bro. Suppose you are throwing a dice and you wish to have a number greater than 6. Okay, suppose you are throwing a dice and you wish to have a fractional number. It's not possible. So impossible event is 0. Probability of an impossible event is 0. Now probability of a sure event is 1. Okay, like suppose that you are throwing a dice and you wish to have the natural number less than equal to 6. So you know that it will come under everything, means 1, 2, 3, 4 and 5 will be the favorable case. So it is 6 by 6. Okay, so it is sure event. Then we have to understand two more things, that is odds in favor. Okay, so this is the ratio. Here you have to write number of favorable outcome by number of unfavorable outcomes. It is the ratio of favorable outcome by unfavorable outcome count. Okay, then we have odds against. This is reverse, number of unfavorable outcome by number of favorable outcomes. Okay, now try to understand this thing. Like I'll tell you how to write down the sample space or the number of sample space. Okay, so first I'll go with count. Okay, number of elements in sample space. Okay, so my idea is, it is number of possible outcome. Okay, to the power number of times. Suppose you are throwing a coin, so you know that the number of possible outcome is 2, either head or tail. Okay, and you have thrown coin, you tossed a coin twice, thrice, 4 times. So you have to write down that thing on the top of the 2. If you are throwing a dice, you know the total number of possible outcome while throwing a single dice is 6. And if you have thrown 2 dices, you have to put 2 as the power, 3 dices, 3 as the power. Okay, now suppose that you have thrown 3 coins. Okay, so you know that the number of possible outcome will be what? Coin is 2, number of coin is 3, so 2 power 3 is 8. Okay, so how will you write? Look at this, you will be writing head, you have to do half of it, it is 4. So head, 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 4 time head, 4 time tail. Okay, first do the half, that many times write head, that many times write tail. So it was 4 earlier, now again do half. So 4 by 2 is 2, so now 2 times head, 2 times tail, 2 times head, 2 times tail. Now half again. So head, tail, head, tail, head, tail, head, tail. Okay, so if you are 16, means 2 power 4, then do half, so 8. So 8 times head, right? And then 8 times tail, then half again, 4 times head, 4 times tail, 4 times head, 4 times tail, then again half, 2 times head, 2 times tail, 2 times head, 2 times head, again half, 1 time head, 1 time tail, 1 time head, 1 time tail, and so on. So this way you will find out the number of possible outcome, or uh, like the elements of sample space. I hope the idea is clear. Let's jump on to the question part, so that we can build better understanding about the concepts as well. So see you guys in next session of MathFlix.